So let's take a look at this problem, this 33, this variation problem. It wants us to write an equation that represents the described relation, and it also wants us to determine the constant of proportionality. So I have this variable r, and it varies directly with t. So I know that's a multiplication. If it had it said inversely, it would have been division. Had it said jointly, I would have expected another variable besides t. So this is the initial model, and then it gives me some values that when t is 4, the r is 18. So we're able to determine this constant of proportionality, divide each side by 4, reduce that, and 9 over 2. Now I don't care if you leave it, you can leave it as a mixed number, and if somebody did put it as a decimal, that's fine too. But I'm just going to, it wants to write the equation. There's my initial equation. Here it is, the constant proportionality. So I always usually come back with that equation, and since I now know what k is, I just go ahead and put it on there. But since it's asking you just the equation and then the constant proportionality, you could leave that. So let's put an or here. I would be fine with that answer. Let's move on to the next one because it's going to be a similar type of problem. We'll just do it all in one video. So we have w, and it varies jointly. So I'm thinking that it's multiplication like when it varies directly, but now I'm expecting more than one variable to follow, and I see that it's jointly with x. Now, the square of y, be careful there that many people interpret the square of y incorrectly by thinking it's a square root or something silly, something silly like that. The square of y means y raised to the second power, that y is being squared. So there's my initial equation. I can now, as w and x and y change, the k is always going to remain constant. So they give me enough information now to determine what k is. They say that w is 120, that x is 5, and that y is 4. So all I have to do is take 120 divided by whatever 5 times 4 squared is. Probably 120 divided by 80, but let's jump in and check on a calculator. I'll just give a decimal number for this one because it doesn't matter. Now it does matter when I divide, since I'm having a product here in the denominator. I do need parentheses around that denominator. Which button is the squared? Is it that one? Yeah. 1.5 or 3 halves if you wrote it as an improper fraction. So they wanted the equation, they wanted the constant of proportionality, and it's fine to come back in and say this equation is always going to be w equals 1.5 times x times y squared. That constant remains constant as x and y change. That's going to affect the w, but does not affect the constant. Now here, it will have us go one step further. Let me show you what I mean. I've got a that varies directly with s, but inversely with r. So when I see inverse, I'm always thinking division. It's now going to give me information about a and s and r so that I can determine that constant k. A is 8. I'm going to figure out what k is. This s is 12. And this r is 15. So this k is 8 times 15 divided by 12. So what do we get for that? Let's jump to the calculator. In my numerator, in parentheses I have 8 times. I guess I could have reduced it myself, but 10. Yeah. It's hard for me to see it when that's shrunk up too small. So let's come back to the original equation. And now I know that K is 10. So I know that A is equal to 10 times S divided by R. So now on the last sentence here, it wants me to find the value of A when S and R are these given values, 9 and 4. So we substitute it in and we get our answer here. Let's jump to the calculator. 10 times 9 is 90 divided by 4, 22, yeah, 22.5. So that's all it's asking us for. This is what it wanted, this value of A. But to get that value, you had to set up the correct equation. You had to solve for the correct constant of proportionality. Then you had to use your equation with that constant to get this 22.5. So that's it, and I'll talk to you later.